I first want to thank the organizers for inviting me to this stimulating conference, particularly in one of the most beautiful cities, Venice, which I have visited. And I consider myself as a scientist working on climate change, really in the trenches, digging deep. And it's just very important for scientists like me to come out of the trench and see what the rest of my colleagues are working on. So for that, again, thank the organizers. Dr. Carr already led very nicely into what I'm going to talk about today. Let me just start with an perspective. Our atmosphere is just a thin shell on this planet. Bulk of the atmosphere, about 90% of it, is within the first 15 kilometers. And it's in this thin layer that we are dumping many pollutants, including greenhouse gases. And I'm going to give you a flavor of what's the consensus opinion among scientists about how our climate is responding to this pollutants. I just want to start with what my own field of expertise. I started out about 30 years ago as a theoretician and modeler of climate systems. And over the last 2 decades, I've been making measurements, particularly with aircraft, and also we have set up observations. This is a site in the Maldives. And what I see from my observations and the aircraft is really not too encouraging a picture. So unfortunately, I don't have an optimistic view like what Dr. Carr presented. For a long time, we have known that we as humans have become a major force on the planet. In fact, one of the earliest recognitions was by the Italian geologist Antonio Stoppani, where he's talking about what we are doing to the planet as a telluric force compared to the greater forces of Earth. And I think Professor Rubio already alluded to that. One of the major issues, of course, the population increase. And this is sort of a nonlinear scale and shows in the last 300 years, and just in the last 50 years, most of the human population was added to the planet, about 3.5 billion. And we clearly see the impact of it on all possible indices, and I'm just going to touch on few. And sort of lists a series of issues, what's happening on the surface of the Earth, and so 50% of the land surface has been transformed. And just in the last century, we have doubled the land use and so forth, and also 50% of the fresh water has been used by humans. And I'm going to touch on some of these. And again, the population issues are mentioned here. And the energy use, Dr. Carr alluded to that. The first index of our impact on the environment, this is really an icon for those who are working on climate research, is that the carbon dioxide concentration has increased from late 1950s by almost 30%. This is a measurement by my colleague, Professor Dave Keeling at the Scripps Institute of Oceanography, who passed away a few months ago. And the first question is, well, nature also changes, so let's compare what we are doing to what nature is accustomed to changing. So this shows, for the last 500 years, the evolution of the carbon dioxide concentration in the atmosphere and the temperature of the planet. These are all measurements that are made in the Antarctic, and what we see here is our change compared to what's been happening and what's called the glacial and interglacial cycle. As you know, the Earth goes through ice ages and interglacial. The most important issue in terms of what we are doing to the environment is an unfortunate combination. We happen to be on interglacial era right now. The climate is warm, and on top of that, we are dumping the greenhouse gases. So let us briefly understand why we should worry about this carbon dioxide. By the way, carbon dioxide is what anything you take, you burn, carbon and the hydrogen of the fuel, it becomes carbon dioxide and water vapor. And this carbon dioxide increase we see no matter where we go on the planet, Arctic, Antarctic, tropics, wherever, in the middle of the ocean. And we also see this increase from surface as much as 50 to 100 kilometers above the surface of the Earth. So basically, we have covered the planet with a blanket. And so why should we worry about this blanket of the gases? And just to give you a brief lesson on how the climate system is maintained, the fundamental energy source is incident sunlight. Not all of it is absorbed by the planet. We reflect about 30% back to space. So about 70% of the sunlight, it goes into heating the planet. And the planet in turn responds by heating and then giving off this energy as infrared energy. And we see it with infrared cameras. And now let's talk about this blanket. The metaphor I can give you is that on a cold winter night, you cover yourself with a blanket and it keeps you warm. It's not because the blanket is giving any heat to you, it's simply trapping your body heat. In the exactly same way, the carbon dioxide traps the body heat from the planet, infrared energy. And we also know how much heat has been trapped over the last 100 years. It's equivalent to making the sun shine brighter by 1.25%. That's a huge amount of energy. And until about, this was really the first scientist who quantified this heat trapping effect is a Swedish chemist, Svante Arrhenius. He was a Nobel Prize winner in physical chemistry. Until mid-1970s, we used to think that CO2 was the main greenhouse gas. And this is where I accidentally stumbled into this problem about in 1975 or 30 years ago, pointed out that carbon dioxide is not the only greenhouse gas. There is other more insidious gas in the atmosphere, chlorofluorocarbons. This comes from release of refrigerants and propellants. All our refrigerators used to use this. And the interesting thing about the chlorofluorocarbons is that my work showed one molecule of the CFC trapped as much heat as 10,000 molecules of CO2. So suddenly, as human beings, we have invented a molecule which is the most potent greenhouse gas on the planet. And since this was covered about 30 years ago, one of the first probably papers went into the headline of the New York Times, and this is because we used to be worried about the CFCs and the impact on the ozone. And we all know the story about the Antarctic ozone hole, and so the CFCs are bad. But their greenhouse effect is still lingering in the planet. And as soon as that work was done, a whole host of gases were added to the planet. It became clear in the last 30 years, carbon dioxide is not the only gas. We are adding, unfortunately, over tens of gases which all trap the planet's heat. Still, carbon dioxide is a major greenhouse. So we are dealing with a whole host of problems in terms of the greenhouse. So the main question is, how large is this warming? And how soon is it going to descend on the planet? So I teamed up with a meteorologist about 25 years ago. We published this paper that if our theories are correct, then we should see this warming by the year 2000. And that was when over 1,000 scientists gathered together into this intergovernmental panel of climate change and concluded that we are seeing a clear signal of the human impact on the planet. This shows the temperature record of the Earth. We started out very cold the early part of the last century, and the planet has been going through a warm period, then relaxed, and what we have seen in the last 3 decades is a rapid rise in the planet's temperature. So overall, the warming trend has been about 0.5 degree Celsius. And you know, I want to a little bit touch on the controversy. What we know, and there's no controversy about this, that the planet in the last 3 decades is much warmer than what it has been in the last century. Very few of us argue about this. The key question is, why is this warming? How much of it is due to human activity? And again, we have to rely on models, and our climate models suggest without the greenhouse gas increase, it would be very difficult, if not impossible, to explain the steep warming trend of the last 3-4 decades.